This is the fire-resistant retrofit assembly. So the approach for this assembly is as if we were coming to do an exterior renovation. So that would be pulling off the cladding and then replacing it and replacing the windows as well, and without touching the interior at all. So one thing that we did is to add extra insulation value to the building without having to make any changes to the interior, is that we added 4 inches of exterior mineral wool. So that helps to make it that fire-resistant retrofit assembly, and then it also helps to eliminate any thermal bridging that might exist within the building by wrapping that entire building in that mineral wool. With approaching it as if we're taking off the entire exterior, we've now used a WRB as the air control membrane. So we have to tape all the joints in this WRB. The reason that we decided to make that exterior WRB now the air control layer is that if we're not doing any changes to the interior, we're not going to be able to get to that old air control layer, which might not be very well done back in the days when this building was built. So we've approached this as if it's an older building with just a 2x4 structural wall, and then therefore that's why we added the exterior mineral wool. Part of what makes this assembly fire resistant is that we've used thermally broken metal girts to actually attach the mineral wool to the wall assembly, and then we attach strapping, rain screen strapping to the outside of those girts. If we wanted to make it even a bit more fire resistant, we could use metal strapping instead of wood strapping, but wood strapping will do because these girts are what is actually holding the insulation onto the wall. And then this strapping has created a rain screen for us. This mineral wool can be to the outside of the WRB because this mineral wool can handle moisture, and moisture will still flow down it and drain away at the bottom of that rain screen and assembly. The window installation for this assembly is very similar to standard construction. So we did a sloped sill on the bottom, and then we did our peel and stick membrane, waterproofing membrane. We do the one on the bottom, cut the corners so that it can fold over each side. Then we do the butterfly cuts in the corners to make sure that that little cut that we had to make is nice and watertight. And then one peel and stick membrane going up the side to make sure everything is nice and watertight. Then we install the window, and then we tape the window flange to the framing, and then we can't see it behind here, but we would also then bring that WRB over the window flange and then tape that WRB to the window flange as well, maintaining that air control layer. On this side, we have a longer straight wall without a window. So here we can see we've had to attach the rain screen strapping with self-tapping screws to go into these metal girts that we've utilized. I wanted to show different methods of being able to seal a penetration through our air control layer. So with this, you can buy these custom gaskets from high performance manufacturers, and it actually is a peel and stick membrane that we can stick to the exterior. And then this is a rubber gasket inside of it that had a small hole, and then that wire pushes through that hole, and that rubber gasket seals nice and tight to that wire. So a nice, simple way, easy, fast way to make sure we maintain airtightness through penetrations. Coming back to these girts that we're using, I said they're thermally broken. So what that means is that they've used a piece of actually insulation at the back there. So what that does, since metal is a very, very good heat conductor, we break that thermal bridge of that metal girt coming back, and then that eliminates heat loss through the wall assembly. On the interior of this assembly, we're approaching it as if it wasn't being touched at all. We don't have drywall on just so that people could be able to see, but we would assume that the drywall gets left on. With the window installation, to maintain that airtightness, we've taped the exterior flanges, but we cannot tape the bottom sill. So in order to maintain that airtightness, we have used spray foam around the window frame and on the bottom as well. So then that spray foam seals to this WRB sill flashing, and that maintains that air control layer there. With the window being installed at the framing layer, we do have to have custom trim returns on the exterior and custom flashing as well. So we do have to have custom through flashing made up at certain points that are required. With this assembly, the roof wouldn't be coming off. So if we were able to actually have a roof on here, we would show that we would have to have this air control layer transferring from the exterior, either coming and transferring in to tie into that air control layer poly on the interior, and then we would have to do a bunch of attic sealing as well to make sure that that attic is as airtight as possible. Or we would have to have a detail showing that this air control layer goes up and ties into the exterior of the existing roof, maintaining that air control layer around the entire building.